Okay, we're going to continue going over the 2018 geometry exam. I'm going to be going over problems 6 through 10, and make sure you write down any notes or anything I ask you to write down. And hopefully you actually tried this problem before, and you can see what you did wrong or what you did right. All right? So let's get started. All right, in the first problem, it says, in the diagram below, AC, so AC would be A, C, has endpoints with coordinates A is negative 5, 2, so that's going to be obviously your A, and your C is 4, negative 10. All right, the question is, if B is a point on AC, all right, so if B, so that what they're saying is, if there's another point B that's placed on this line segment, and AB to BC, right, so this part, equals 1 to 2. So that means a 1 to 2 ratio. That means that BC would be twice as big as AB if it's a 1 to 2 ratio. What are the coordinates of B? All right, so you have to think of B being this point, and it's somewhere on this line. Okay, it's somewhere on this line, but where is it such that BC or AB to BC would be a 1 to 2 ratio? So you should think to yourself, okay, let's just say it was right here. Does that look like BC is twice as big as AB? No, I don't think so. Well, what about if I kept moving it, right? Is BC, is that twice as big as AB? No, that's actually going in the wrong direction. So you should think to yourself, it's probably somewhere up here, okay? It's got to be closer to A in order for AB to BC to be a 1 to 2 ratio. All right? So now, this is what we're going to do. We're going to find the slope, and then we're going to do these steps. So write down the slope. Slope is simply rise over run. So I'm going to move this B. We're not sure exactly where it is. I'm going to move it. Slope is rise over run. Also can be seen as, or you can say it as the change in Y over the change in X. All right? We're going to find the rise of a run from A to C. And then we're going to divide the rise and the run by the total number of parts. Where we're going to get the total number of parts is looking at this 1 to 2. You just add 1 plus 2, and that means we're going to have 3 parts we want to break this line into. All right, 3 parts. Let me write that a little nicer there. 3 parts. Okay, 1 plus 2. If it was 2 to 3, it'd be 5 parts. Okay? All right, so let's go ahead and do that. So let's find the rise over the run. All right, so from A to C, I'm just going to go down here, right? And so that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's actually negative. So we'll say our rise is negative 12. Then my run is going to be over here. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So my run is equal to 9. All right? So my rise over my run, or my slope, is negative 12 over 9. Now, what you want to do at this point, our next step, is to divide the rise and the run by the total number of parts. So we're actually going to divide this by 3, divide this by 3, and that is equal to 4. And we'll say negative 4 over 3. So what you're going to do from A now is you're actually going to count down 4. So I'm going to go 1, 2, 3, 4, and then 1, 2, 3. And now I'm going to count again. 1, 2, 3, 4, 1, 2, 3. Okay? Now, so those are my points. So now you think to yourself, I'm going to move B now. Where should B be? It should either be here or here. Well, based on our evaluation we talked about before, the only place it can be is right here, okay? That's going to be a 1 to 2 ratio, all right? Let me go and show you right here. So A to B is going to be here, and then B to C is going to be here, and B to C is definitely twice as big as A to B, okay? So there we have it, and well, now we need to figure out what point that is. Well, that point, if we count from this point, it's negative 2, right? So that is my point for that. Okay, let's look at problem number 7. All right, here it says an ice cream waffle cone can be modeled by a right circular cone with a base diameter of 6.6 centimeters and a volume of 54.45 pi cubic centimeters. What is the number of centimeters in the height of the waffle cone? The height of the waffle cone. All right, so a couple keywords. You have diameter, you have volume, and it's going to be a right circular cone. All right, right circular cone. So those are our 3 things we want to focus on. Remember, diameter is actually the line that goes through the center point of a circle. All right, it's different than the radius. All right, so what we need to do, and I have a picture of a cone over here that I put for you to, I know we all hopefully know what a cone looks like, but I put it over there just to help us out. And now let's go back to our reference sheet. You actually, on your reference sheet in the back of the test, you actually have the volume of a cone formula, which I've circled in red here. All right, we're going to need that. So I'm going to go back, I'm going to write that down. Okay, I'm going to write that down here. All right, so let's go ahead and write that down. All right, so it's going to be V is equal to 1/3 pi r squared h. So looking at this formula, it has 3 variables: the volume, the radius, and the height. You need to have at least 2 to find the other 3. I'm sorry. You need to have at least 2 to find the other 1. And usually, on easier problems, they'll give you the radius and the height and have you find the volume. Once you get into geometry regions or a higher level class, they're usually not going to do that. They're actually going to give you the volume, give you something else, and you find the radius or the height, okay? Because it's a little more tricky to do that. So in this case, they didn't even give us the radius. They gave us the volume, so let's write this down. We need to find what the radius is. Well, how am I going to find the radius? Well, the radius is actually going to be the diameter divided by 2. Because remember, the radius is half. So the radius is going to actually be 3.3. Okay? So that's our R. And then our volume, our V, is equal to 54.45 pi cubic centimeters. So we have those 2, and we need to find the height. That's what we are looking for. So let's just fill these things in here. All right? So what I'm going to do is I'm going to say 54.45 pi is equal to 1/3 pi times 3.3 squared times the h. All right, the nice thing about this is everything's being multiplied here on the right-hand side and on the left. So it's pretty simple. All you have to do is take this, divide this by 1/3 pi 3.3 squared, right? Then you do the other side by 1/3 pi times 3.3 squared. And what we're going to have here is all this is going to cancel out because it's being divided by itself. So what you're going to have to do is just divide the left-hand side. So I'm going to go ahead and do that. All right, so let's go ahead and I'm going to use my alpha y equals enter to get a fraction. I'm going to do 54.45 pi. And then on the bottom, I'm going to divide by 1/3. I'm going to use fractions because I don't want to use decimals because they won't be as exact, especially with 1/3. You're better off using 1/3 than 0.33, okay, because 0.33 is rounding. All right, so 1/3 pi and 3.3 squared, hit enter, and you end up with 15. So that is my height. My height, h, is equal to 15. Pretty simple as long as you can manipulate a formula. If you can manipulate a formula, and remember that they give you the diameter, that's the trick here, they give you the diameter, you have to figure out what the radius is. All right? All right, so we're going to make sure and write those things down, and we'll come back to do number 8. Okay, look at number 8. It says the vertices of triangle PQR have coordinates of 2, 3, 3, 8, and 7, 3. under which transformation of PQR are distance and angle measure preserved? Remember, preserved, that's another way for saying stays the same or maintained. We've said maintained. All right. However you want to think about it, preserved, you need to know what it means. Okay. Now I want you to write down these notes over here. And what they say is, anytime that multiplication is involved, distance will not be preserved or maintained unless it is being multiplied by 1. Remember when we were doing dilations? If you had a dilation with a scale factor of 1, you had a congruent shape. Otherwise, any other thing you multiply by, the sides are not. Now, the angles will stay the same, but the sides will not. Okay? So if I look at these 4 answer choices, all of them except 1 have something being multiplied. So if you look at 1, if I look at 1, do you see how you have 2x and 3y? That means that the x value is being multiplied by 2, the y value being multiplied by 3. That means the distance is going to change. The side lengths are going to change. Okay? Same thing here for number 2. You have 3y. That means your y value is being multiplied by 3. So that's no good. So 1 and 2 are no good. On number 3, your x value is being multiplied by 2. That's no good. That's going to change distance. On number 4, both of them are being added. That's just like a translation. Remember, in the translation, the sides and shape are preserved, and you have a figure that's congruent. So number 4 will be our answer. Okay, let's look at number 9. Number 1 is very tricky because I know students, the mistake students make is going to be the same. I know that a lot of students are going to make the same mistake. So let's look at this problem. It says in triangle ABC, so ABC is here, ABC, as shown below. AC is extended to point B, out here, with the measure of angle DAB equaling 180 minus 3x. So they label it for you, that's nice, that's this angle. Measure of angle B on the inside is 6x minus 40, and C is x plus 20. All right, so they label it for you. And that's nice. Now they ask, what's the measure of angle BAC? So that's going to be this angle right here, BAC, okay? Now, they give you the exterior angle of a triangle, all right? So, in this case, there could be other ways to do it, but I want to make sure we understand the exterior of a triangle theorem. There is a theorem or a rule when you're given the exterior angle. This here is an exterior angle. All right, exterior angle of a triangle. And here's a rule that I want you to write down, okay? The exterior angle of a triangle theorem, all right? Exterior angle of a triangle is equal to the sum of the 2 non-adjacent interior angles, all right? So this angle on the outside, so this one here, is equal to the sum of these non-adjacent. So the ones it's not attached to, okay? So our equation, based on that theorem, which you need to write down, our equation is going to look like this. So let's go ahead and write down what our equation should look like here. It should be 180 minus 3x is equal to 6x minus 40 plus x plus 20. Okay, that equation, you know what that equation says? It says that that exterior angle here is equal to the sum of the 2 non-adjacent interior angles. All right, now we can just go ahead and solve this. We can go ahead and solve this. So we have 180, no like terms on the left. There are like terms on the right. So I have 6x plus x, that's 7x. And then a negative 40 plus 20, that's minus 20. Minus 20. All right. Then, from there, you have a couple different options. I'll just add the 20 here, add the 20 over here, and that's going to be 200 minus 3x is equal to 7x. Then I add 3x, and you get 200 is equal to 10x, then you divide by 10, and you end up with x is equal to 20. Now, they very nicely put 20 as an option. However, look at what the question's asking. It's asking what's the measure of BAC. That's going to be this angle here where we put the blue question mark that I just outlined in red. Okay, that angle is not necessarily 20 degrees, all right? And that's not even x. You know, it's not, you know, it's not our x, okay? So what you could do at this point is what you'd have to do is take this 20, plug it in here, so that's going to be 180 minus 3 times 20, which is 180 minus 60, which gives us 120. That means this angle is 120 degrees, which means over here must be 60, because they are a linear pair. All right, they are a linear pair, and they add up to 180. Okay? So there you go on that one. We'll come back for the last one. All right, this is something, if you are watching this in my class, we have not yet done this. Or if you are from my class and you're watching this shortly after I made it, we have not yet gotten to this topic. However, it'll be good review. So let's look. It says circle O is centered at the origin. In the diagram below, a quarter circle is graphed. So this is my quarter circle right here. All right, this is my quarter circle, 1/4 of a circle. Which three-dimensional figure is generated when the quarter circle is continually rotated around the y-axis? All right, so you really have to do some visualization here. What is this thing going to look like? Okay, now you have 4 options. You have 4 options here. So I actually brought up pictures of all these. So we have a cone and a cylinder, right? Hopefully you guys are familiar with a cone and a cylinder, all right? And then also the other two that you may not, definitely number 4, but you may not be as familiar with these, a sphere and a hemisphere. So if I rotated this shape around the y-axis, right? Just imagine it rotating around, right? What is it going to look like? Well, hopefully looking at these pictures, you can see it's going to look more like this hemisphere, right? Okay, so I'm not going to talk much about that. You really have to visualize it rotating. Imagine that axis spinning and what would be created, okay? So that's going to be our answer there, and nothing for you to really no work to show. You just really have to picture this one, okay? So we're done going through 6 through 10. Hopefully I answered any questions that you may have had about the problems.